I want to talk about heating and cooling things. So we have looked at heating things before. Here's one example. This is an infrared image, an infrared video of me scuffing my feet on the floor. And you can see that when I do that, the floor gets warmer. You can see the little brighter spots in the floor. If you turn the foot over, you can see that the foot is also warmer. So when you take two things and you rub them together, they both warm up. Okay, now here is a question to think about. We'll answer this at the end. Suppose I have a fan in a room and I turn on that fan. What does that fan do to the temperature of the room? A, the fan decreases the temperature of the room. B, the fan increases the temperature of the room. C, it just moves the air around and doesn't really change the temperature. We'll address that at the end. Now the next question is, how do you make things hot? We saw that if you rub two things together, they both get hot. But you can also make something hot by running electric current through a wire. So this is a nichrome wire, running current through it, and it gets so hot that it glows and it just looks cool. Okay. But how do you make things cool? Well, here is a video of this is from Frozen, right? Ice is cold. So if you get ice and you take it somewhere and you put it in contact with something that's not cold, then there is a interaction between the cold thing and the warm thing. The cold thing gets warmer, the warm thing gets colder. So cooling stuff is important. If you have something cold, you can make something colder. Okay, not colder than the thing that you started with. You can't make it colder than the ice you started with. Okay, but there's another way to do things. This is a great example of making something cooler by making it hotter. And this is one of the most important things about cooling. We always want to make something cool by making something hot. So in this example, and you can do this yourself, and you should, you take a rubber band, you stretch it, and when you do that, that rubber band gets warm. If you hold it there and let it reach room temperature, it'll cool. It's hotter than the room, so it'll cool off. And then when you let it shrink back, it gets colder. You can see that in this infrared video right there. So if you want to do this, take the rubber band, pull it, touch it to your lips so you can feel it's warmer, hold it, and then let it collapse, and then you can feel that it gets colder. It's a really great demo. I recommend that you do that. So here is how that works in the real world. This is an air conditioner. It does something very similar. On the left here, we have an infrared video of a can of compressed air. When the liquid in the can expands, it cools off. When you have a phase change, you cool off. You could imagine just compressing the gas and then letting it expand, and it will also cool off. And that's what happens over here. This is it's a heat pump. It's actually an air conditioner. What happens is there's some parts in here. They compress a fluid. The fluid expands and cools off. And then when you compress it, you bring it outside and let it cool off to outside temperature. You bring it back in, you let it expand, and it cools off, and you cool off the inside temperature. So that's how a heat pump works. But there are other ways to make things cool. Here's one way, and that's changing the phase of a material. If you go from a liquid phase to a gas phase, that takes energy. So that works really well with water. If you take water and let the water evaporate, it will cool things off. This is how humans cool. We sweat. The water gets on the surface of our skin. That water turns from a liquid water to a gas water, and that cools off the skin. Now, if you're in a very humid climate, like I'm in, then there's a lot of already humid water in there. There's water vapor in the air, so that water doesn't evaporate very fast, so you just end up being sweaty. If you go to a dry area, you don't even know that you're sweating because the water evaporates and it cools you off. Okay, now here's a fan. This is a fan. Does the fan actually cool things off, or does it not? So this is an electric motor in here, and it spins these blades right there that pushes the air. So what does that do in terms of helping humans? Well, let's look at an actual infrared video. Is this a video or picture? It's just a picture of a fan. So this is a ceiling fan, and you'll notice here in this motor, this is the ceiling. It's very hot outside. But the motor right there actually gets hot, right? Because I'm running electric current through that motor, and that's going to make it hot. So the fan gets hot. It does not decrease the temperature of the room. It increases the temperature of the room. However, it works very well with humans because humans have that water, that sweat. And so as the air moves over the human, it can help increase the rate of evaporation and cool you off faster, because moving air makes it increase faster. So in this case, you can see another infrared picture. This is me with my shirt on, and I put a wet hand on my shirt, and you can see the parts that are wet are cooler because that water is evaporating. What about this famous question? So here's a question: could you just open up your refrigerator and cool off in your house? No. The answer is no, because the refrigerator has a heat pump in there. And what it's doing is it's making something cold on the inside by making something hot on the outside. So it's the same thing as having an air conditioner, but putting the air conditioner in your house. So if you take that rubber band and stretch it and then let it go back, you're not really gaining any cooling factor there. So the same thing's true here. If you open that refrigerator, the inside is cold because the outside is hot. But now both the inside and the outside are hot and cold, and the effect actually makes the whole thing hotter. So you may get a temporary relief by opening the refrigerator, but long term it won't work. I do want to say one more thing about heat pumps. This is a heat pump. You know, I had trouble imagining a heat pump as being more efficient than an electric heater, right? Because an electric heater, you're just running electric current through the wire, it gets hot. Nothing simpler than that. But the heat pump is like a reverse air conditioner. Instead of cooling the inside of the house, it's cooling the outside of the house. And it does that by heating up the stuff inside. And you get an advantage because you're starting with air that already, even though it's cold, it already has some temperature to it. It has some thermal energy. So when you use that on the inside, you're not starting from scratch. When you're running electric current through a wire, you're just heating up straight, right? You're not taking some hot air. You're not taking the air from outside, but you're taking the thermal energy from outside to use that to heat up the energy inside, even if it's really cold. So heat pumps are more efficient than electric heaters in some cases. In some cases they're not, depends on the temperature. Okay, the point of this whole thing, easy to make things hot, not easy to make things cold. Talk to you later.